Hi, in this video I will present our submission to ICRA 2024. In a conventional vitreoretinal surgery, the surgical tools are inserted into the posterior segment of the eye through the channels placed on the sclera, namely trocars. The trocars limit the movement of the tools, restricting it to their remote center of motion point. The challenges for a robotic platform would be an automatic introduction of the tool into the eye through the trocars and dynamic adjustment of the robot's RCM point due to the changes in the trocar position. Our proposed solution is to use a mono-camera system having the least impact on the surgery room compared to the other tracking systems, and develop a robust trocar post-tracking method which could be used for the guidance of the robot. In this order, there is a need to create a dataset. We place a trocar on an eye phantom with a fixed position relative to an Aruku board. For one specific frame, we run a PMP algorithm to find the pose of the trocar to the camera. Having the board pose to the camera from the Aruku markers, in this frame the pose between the board and the trocar can be calculated. In any other frame, since the pose of the trocar and the board is known, tracking the board would provide us the trocar pose. We use the trocar pose together with its 3D CAD model and PyRender to create the segmentation masks. On the right, some samples of the dataset can be seen. Our learning approach is inspired by the SC60 work combined with a YOLO 7 object detector. This video demonstrates the result of the model on our data. For the purpose of the estimations, the board is not used, but for the evaluations, the results are compared to the ground truths based on the Aruku board. The results are from a set of 200 images providing a rotation error of 3 degrees on its Z rotation axis. Due to the trocar symmetrical geometry, the rest of the rotation errors are not relevant. The method also provides a 1.52 mm error on the Z-axis translation. The inference rate also shows the potential of having 15 to 20 frames per second, making the algorithm real-time. To finalize, you can see a demonstration of the method on a scene without any markers with multiple trocars. It's again important to mention that the only important rotation to consider is the one around the trocar axis of symmetry as shown on the bottom left figure. Thanks for your attention.